we're again going to use the divergence theorem to calculate the flux of F across S. F in this case is the quantity of xy plus 2xz times I plus the quantity of x squared plus y squared times j plus the quantity of xy minus z squared k. S is the surface of the solid bounded by the cylinder x squared plus y squared equals 4, and the planes z equals y minus 2 and z equals 0. Well, let's see what we're looking at. I'd actually like you to see what we're looking at. Go ahead and pause the video and draw the solid, please. Here we have our cylinder of radius 2. The top is the xy plane, and the angled face here is the plane z equals y minus 2. Now, folks, a distinction here. S is the surface of the solid, and we're asked to find the flux of F, but we're going to do it by computing the triple integral over the region E. And for the region E, we see that z is bounded below by the plane and above by 0. So y minus 2 is less than or equal to z, which is less than or equal to 0. As for the two-dimensional trace in the xy plane, we have that x squared plus y squared is less than or equal to 2. It's that disk of radius 2 on the top surface. That our trace is a disk means we're probably going to use cylindrical coordinates. With that in mind, I'd like for you to go ahead and find the divergence of F, set up the integral, and get it as far as you can. Just want to make sure you're on the right track here. The divergence of F is going to be y plus 2z plus 2y minus 2z. The 2z's subtract out. We end up with 3y. The integral of our flux is the triple integral over E of the divergence of F dv. And so it's the triple integral over E of 3y dv. Converting into polar coordinates, we have theta goes from 0 to 2 pi. R goes from 0 to 2 because we were talking about a circle of radius 2 for the cap of the cylinder. And then remember we said that z went from y minus 2 to 0. Expressed in terms of cylindrical coordinates, we have a lower limit of integration for z of r sine theta minus 2. An upper limit is 0. Now go ahead and continue on if you need to. Well, there's a lot of stuff on the screen now. We integrated, well, first we combined 3r times r to 3r squared. Integrated with respect to z, that gives us one factor of z. Evaluating from 0, well, the upper limit of 0, lower limit of r sine theta minus 2 would introduce a minus sign. So I've actually expressed that as 2 minus r sine of theta. Just distributing inside of the integrand, we have 6r squared sine theta minus 3r cubed sine squared of theta. We're going to integrate that dr d theta, r from 0 to 2, theta from 0 to 2 pi. Integrating with respect to r is going to give us 2r cubed sine theta minus 3/4 r to the 4th times, and here I'm using a power reducing formula for the sine function, so 1/2 times the quantity of 1 minus the cosine of 2 theta. We have integrated with respect to r, evaluating at the endpoints 0 and 2. It's going to yield us negative, oh, and also integrating with respect to theta. Just went ahead and skipped ahead there. Negative 16 cosine of theta minus 6 times the quantity of theta minus 1/2 times the sine of 2 theta. Putting either 0 or 2 pi in place of the sine of theta is going to zero that out. And the cosine of theta is the same whether we have 2 pi or 0, and so that term is going to zero out. Altogether, we end up with negative 12 pi.